I welcome all of you in today's lecture. I am very much thankful to everyone being here today. Now I will share with all of you our today's presentation. So in the last lecture we was in that the last you can say the article of this particular module 2, drainage in excavation, necessity and methods of dewatering. Okay. So in the last lecture we was in that the overview of drainage and dewatering technique. So the constructions of any type of structures, footing of various buildings, powerhouse, multi-story buildings and many other structures require excavation below the water table into water bearing soil. Okay. So such excavation require lowering the water table below the slope and bottom up excavation to persist revealing or slogging the slope and to ensure dry and firm watering condition, or you can say the working condition for construction operation. Therefore, the dewatering an important consideration for construction managers, especially during excavation and foundation stages. Okay, thereby uncontrolled groundwater can flood excavated areas. Groundwater can flood excavated areas, damaging construction material and equipment. Water can also collapse trenches, collapse and flooding, threatening the construction worker in the area. Therefore, the selecting an adequate dewatering method based on soil conditions and water table and is an important step before the the constructions of any foundations. So in the last lecture we was in that the definitions of dewatering. Okay, so whatever may be the excess water in this picture, you will see that there are certain water. This is the area where we can do the work. So the proper removal of excess water from the saturated soil mass is termed as drainage and dewatering. So we have to ensure for proper condition there should be a dry condition. So for dewatering of this particular water from this working area, we have to select appropriate methods of dewatering. So why one should carry out the dewatering? What are the various functions of dewatering? Okay, so to provide a dry working area for constructions, this is the first functions or the objective of dewatering. Then to reduce lateral pressure on foundation or on retaining structures. So whatever may be the lateral pressure due to the uplift pressure of that water may come on the foundations of any structures, that can reduce with the help of dewatering methods. Then the third important objective behind dewatering is to reduce compressibility of granular soils, then to increase bearing capacity of foundations, to prevent liquefactions due to the upward gradient, and to prevent surface erosion. This is one of the important, you can say, the functions of dewatering. While excavation, if large amount of water will be there, then there will be a collapse of the particular sides of that trenches. So to avoid the erosion of soil at the foundation, so we have to dewater whatever may be the water at the construction area. So to prevent or reduce damage due to the frost haves. So these are the various objective of dewatering process. Now we have the you can say why this topic we have seen in the last lecture important to me and all of you, because we have to excavate the mass excavation. For the mass excavation, then underground utilities and the foundation and substructures. So in case of mass excavation, in case of high rise building foundations, or when we can excavate the foundation for bridge piers, then there will be a possibility of the mass excavation and there will be a possibility of water at the construction area. So in case of mass excavation, this dewatering process is very important. Then underground utilities, for example, in case of municipal corporation area, water supply and drainage facility, if you want to dig a trenches for water supply and drainage, then there will be a possibility of watering which come from the nearby area into the excavated trenches. So we have to apply the suitable methods. By applying suitable equipment, we have to dewater that and keep that area for the dry for the working conditions. So in case of water supply and drainage facility, we require the dewatering process and the foundation and substructures. So various types of substructures, for example, or superstructure, for example, powerhouse, then multi-storied buildings, and other so many civil engineering project require the dewatering. So this is the case where we want to generally dewater. So
औरंगाबाद जिल्ह्यातील छोटेश्वर या गोष्टीचं नाव आता दिसतं. कारण इथे जिल्हा परिषद शाळेतील विद्यार्थ्यांनी बक्षिसा लागल्या फळं आणि भाज्या धुण्याचं हे बक्षीस. सगळं टाळण्यासाठी बनवलेलं हे बक्षीस नेमकं कसं
I
आहे?
request all the students, please mute yourself. So here various considerations is also required while dewatering process. So these considerations we discussed in the last lectures. The soil permeability, these things is very important. So according to the permeability of soil, so soil permeability plays an important role in case of the dewatering, because if the porosity of the soil is large, then whatever may be the water which is coming from the nearby area into your actual construction area, then if the porosity is large, then ultimately the flow from the nearby area is very large. So the soil permeability plays an important role. Then volume of water and duration of dewatering operations, then impact on surroundings, that is the pump noise and the drawdown, fluctuation in water table. Then discharge point, then the turbidity, then permit withdrawal or discharges, then standby or backup pump required, union meaning requirements, and uh, specialty dewatering contractor. So certain experienced contractor will require for the dewatering process. So these are the considerations is very important. We have to look into the considerations while dewatering process. Then generally we have the dewatering methods, then surface pumping and pre-drainage methods. So these are the two main dewatering methods we have to use. Now in case of surface pumping, what we have to do generally? If you see here, we require the open pump from the sump. So we require the pumping to pump the whatever may be the water from the excavation ditch or pond during the excavation process. So we require the equipment, diaphragm type pump, centrifugal pump, then hydraulic or electrical submersible pump. These things we require for the surface pumping. So again the surface pumping methods is divided into 3 to 4 subtype. In the next slide, I will show you the surface pumping sub methods. Then the main methods of dewatering is pre-drainage. So what do you mean by the pre-drainage? Removal of groundwater from outside or below the limit of the work prior to excavation. So before starting of the excavation, if the you can say the groundwater is available outside or below the limit, then we require the prior removal of the that water from the before excavation. So such method is known as pre-drainage method of dewatering. Then we required here, see, the well point, deep well, then horizontal drains. So this method by which we can dewatering the process of the groundwater in case of the pre-drainage methods. Now, if you see here, these are the various methods for lowering water tables. The first method is the ditch and sump, then well point system, then third one is shallow well point systems, then deep well systems, then vacuum method and electro osmosis methods. These are the various methods by which we can dewatering the water from our working areas. In the last lectures, this way where we was discussed regarding about ditch and sumps. Okay, so in case of ditch and sump, what we have to do while excavating the trenches of the any multi-storied building, for example, and if the water will be there, then what we have to do? We have excavate the trenches for the dewatering process, like as a trapezoidal ditch. What we have to do in this? We require a pump setup. Okay, so and this is a point where maximum discharge will come. So this is the nearby area of these particular trenches. This is groundwater, and this is the depth of the trenches. Okay, so initially this is the water table inside this particular ditch and sump. Okay, then we have to set up our actual centrifugal pump. So the centrifugal pump is kept on a platform. This is the platform over which the centrifugal pump is kept. Now we have to lower the suction pipe in the maximum discharge point where maximum amount of water will be collected. Then this is known as the a well point or maximum discharge point. Okay, then here we have a delivery pipe. So delivery pipe at the groundwater, the position of delivery pipe is at the ground. So whatever may be the water after starting the working of this particular pump, so the initial water level goes on decreasing. Okay, so this is known as the depressed water table. So this is initial water table, and after pumping this is depressed water table. So whatever may be the difference we will get after initial and depressed water table, the difference in between the initial and depressed water table is known as drawdown. So whatever may be the volume of water will collect at a maximum discharge point. The capacity of pump is selected depending upon the availability or volume of water in the particular ditch and sump. So this is a particular setup we require to dewatering the process in case of the ditch and sump. We require the pump setup, we require a trapezoidal trench, okay, and we require a maximum point discharge. Now you can see here, this is, you can say, the rectangular ditch or trenches. So here this red indicate that this is a pump position, and this is, you can see here, this is the you can say the suction pipe. Suction pipe is inserted in the water, and then we have to start the pump, and this is a simple method by which we can dewater this particular area. Then the another things also we was seen in the last lectures. In this case also, this is you can say the sump where the maximum water will come. So we have to select such point, and we required a hydraulic pump. The pump setup is at the ground level, and then we have to insert the suction pipe at the sump where the maximum water will come. So this is again we have the initial water level, and this is the fluctuator water level after pumping start. So this is also a simple method by which we can dewatering the excavated area and make it dry for the working conditions. Then this is you can say the process for the dewatering. This is the actual area where we want to construct a you can say the bridge piers or any excavation for the foundations. So this type of generally the process for dewatering we have to follow in case of big trenches or big foundations for the any type of the structures. Then this is also we was seen in the last lectures. This is known as the well point. Okay, when the discharge is maximum, then we require the stages. So this is stage 1, this is stage 2, 3 and 4. Okay, so and this is our actual the foundations for the structures. So if the volume of water is very large, then what we have to do? We have to set up a parallel pump or pump in series. So this is the pump first stage of the well point, and this is the second stage of the well point. So this setup we require generally when the volume of water is very large. Now this is also a another the setup. These are the pump in parallel. This is pump 1, this is pump 2, pump 3 and pump 4, and also if required we have to add another pump 5. So these well point systems we required for the larger volume of water will be available, and if you want to dry this particular area of the excavation, then such well point system be required. Then in case of well point systems, we was seen in the last lectures. Generally, the suction pipe which is having half to 1 meter long and 5 to 8 centimeter in diameter, which is lowered in the you can say the water where the larger volume will come, and then this is the structure for the sump pipe. Okay, at the base of this particular sump pipe there is a footwall with a strainer, and at the uppermost portion there is a adapter coupling. So this is a simple construction features of the sump pipe. Then we also seen that in the last lectures multi-stage well point systems. Okay, what we have to generally in this particular multi-stage well point systems. For example, this is stage 1, stage 2, stage 3, stage 4, stage 5 and stage 6. Now this system will generally required for the constructions of bridge pier. The bridge pier is constructed across the river, and if you want to discharge the water, or you can say the dewatering of the construction bridge pier, and if you want to make a dry area for constructions, then this the multi-stage well point system generally we have to follow for the dewatering process. So this system is having a different you can say the pump setup. Then these are the things we have seen in the last lectures in case of multi-stage well point system. When the dewatering of the excavation below the 6 meter to 30 meter. If you see the excavation below 6 meter to 30 meter, so this system is generally operated for 6 meter to 30 meter. So these are the things I have already explained in the last lecture. Then the area where we want to generally dewater the foundations of any structures, any civil engineering structure. So the structure may be the hydro project, then excavation of foundation for buildings, then basement constructions, then laying of deep sewer lines, then tunnel works, then constructions of subway, then water supply project, then land reclamation project, then canal constructions, then the thermal project structure with not too deep foundations, underground tank constructions and bridge constructions. So these are the area where dewatering generally we have to follow. Then in the today's lecture, we are going to learn the deep well drainage systems. Okay, what we have to do generally in case of deep well drainage system, how the dewatering will be done in case of deep well drainage systems. So if you see here, the deep well drainage systems is adopted when the depth of excavation is more than 6 meter below the 16 meter below the water table. So this type of deep well drainage system when we require, when the depth of excavation is more than 16 meter below the water table. So the system is useful where artesian water is present. So here I would like to say what do you mean by the artesian water. Okay, so artesian water is groundwater that flows freely at the surface from an artesian bore or well. It is under positive pressure, that is water flows under natural pressure without pumping. So the artesian water is present, then the deep well drainage system is adopted. Artesian water, earlier I have told you, water flows under natural pressure without pumping. So if you see in case of groundwater, there is a ample water which is freely flows, and if you want to construct any foundations below the 16 meter below the water table, then such kind of water you can see there below the ground, artesian water. So a 15 to 60 centimeter dia hole is bored and casing with a long screen 5 to 25 centimeter is provided. Then we require the submersible pump with capacity to push the water up to 30 meter or more is installed near the bottom of the well. So we have to excavate the borehole about 15 to centimeter in diameter and casing with long screen 5 to 25 centimeter, and we require the submersible pump for 30 meter or greater than that also for the deep well drainage systems. Then in case of the deep well drainage systems, each well has its own pump. If you want to excavate the number of well, for example 1, 2, 3, 4, 5 and so on depending upon the artesian water, then each well has its own pump. A row of deep well are arranged at the toe side of the slope of deep well excavation. Also very useful or helpful where high artesian pressure exists. So such kind of well system generally we have to you can say applied or employed for the purpose of dewatering of the excavation for the foundations. So here in this picture, in this diagram you can see here, this is the first deep well which is having the diameter 15 to 60 centimeter in diameter, and we can excavate up to 30 meter, or if the artesian water is in large volume, then we have to excavate more than that 30 meter also. So 15 to 16 centimeter diameter hole we can excavate below the ground level, and then we have to immerse the submersible pump as we have in case of our building bore motors. Okay, so such kind of borehole system we have to follow in case of dewatering process. Then this is the, you can say, the submersible pump. Then what we have to do generally, if you want to excavate the foundation, suppose the foundation area is here, and before excavation of this foundation, earlier we have to do, what we have to do, we have excavate or drain out all the water from the ground, and then we have to dry this particular area, and then after dewatering, then we have to excavate the foundation. So this is a you can say the pre-drainage systems. Pre means we have to first dewater the area, and then we have to do the excavation for foundations. So this is known as pre-drainage systems. So this is the first stage of, you can say, the deep well. We require the submersible pump, and this is the, if the water table is lower, this is the a lower water table, then the water level will goes on decreasing. Then this decrease in water level table is known as drawdown. Then we have to construct another deep well in the second stage for lowering the water table. Then we have to extract the water from the area below the groundwater. You can say to extract the groundwater. So in this way, in case of deep well, again we have to construct or construct the deep well here again if the volume of artesian water is very large. So in this way, in case of deep well drainage, we have to excavate or we have to discharge the water in pre-drainage situations, and then we have to start our actual constructions. So here, this is again, you can see here, this is the initial water table, and after pumping the water table goes on decreasing. So this is known as the decreased water level, and whatever may be the difference will be in initial and decreased water table. This is known as drawdown. Then then we have to, after lowering the water table, then we have to actually start our excavation. So this is the you can say the application of deep well system for dewatering of excavation in sand or any silty or any gravel type of the strata below the ground level. Then this is the sections. This is the diameter of the borehole, 15 to 16 centimeter. Then these are the, you can say, the structures. This is initial water table. Then this is the first layer. You can see clay. This is the second layer, silty sand. This is the strata below silt, ground level. Then weathered sandstone, then silt again, and then sandstone. So these are the structure below the ground level. So this is a simple method, you can say, for pre-drainage dewatering of the excavation. So after dewatering, you can start your excavation. So this is the excavation you can start after the drainage system. So this is about the you can say the deep well system for excavations of the discharge of the water from the excavated area. Okay. Then I would like to show you. Now in the previous slide, if you see here, this is a structure generally, okay, this is a foundation for the structure, and this area having the water, and if you want to dewater this particular water, then in case of deep well drainage systems, what we have to do generally, you can see here, then see here, first what we have to do in case of now this is the area generally. See here, in case of deep watering system. Now in this area there is a water. Okay. Now we cannot extract directly the water from this area. Why? Because again the water come from the nearby area. So what we have to do in this particular deep well systems for dewatering, we have to in this diagram you can see here. Now this is the first well. Okay, this is bore well, which is having 15 to 16 centimeter in diameter. Then we have to excavate the borehole from the nearby that excavated area, and then we have to insert the submersible pump, and we have to excavate the another bore. This is another bore, okay, and whatever may be the discharge which is coming from all the bores in parallel or series, then this is a, you can say, the pipe. All the bore is connected with the main pipe. So whatever may be the discharge which is extracted, whatever may be the water which is extracted from the ground, all the bore is connected with the main pipe systems, and we have to extract the water. So such system of dewatering you can see here. Okay, such systems. So this is the system by which we can extract the groundwater. So ultimately this area will be dry in case of the you can say the deep well systems. Okay. So if anybody is having the questions in case of the deep well systems, then please raise your hand and ask the questions. If anybody is having the questions, hello, Bhojwani, hello, Bhagyeshri, Sachin Chauhan. If anybody is having the questions on deep well systems, then please ask at this case, at this situation, or at this time. If you are having any questions regarding about deep well excavation and the dewatering process, then please ask the questions. Suraj Lokhande, Bhojwani Kunal, Saurabh.
Yes, sir.
If you are having the questions in case of deep well dewatering systems, then please ask the questions.
No doubt, sir. We
Okay,
got it.
okay. Now we will move to another process of the dewatering. The next process is vacuum dewatering. Okay, so this is also, you can say, a very important methods, vacuum dewatering methods. So this method is used when the permeability of soil range from 10 raised to power minus 5 to 10 raised to power minus 7 meter per second. Okay. This type of method generally used when the permeability of soil ranges from 10 raised to power minus 5 to 10 raised to power minus 7 meter per second. Water cannot be removed so easily from the clay soil whose permeability in this range. Okay, therefore it is required to create vacuum and hence hydraulic gradient. So specially what we have to do in this case, water cannot be removed easily from the clay soil whose permeability is in this range. Therefore, it is required to create a vacuum and hence the hydraulic gradient. So, how the vacuum is created? If you see here in case of the vacuum dewatering, Generally this is a borehole again. Okay, then these are the different materials which is available below the groundwater, or you can say the ground level. Then this is the submersible pump. Here again we have to immerse in the water up to the 30 meter or more than that also. Then this is the suction pipe which is known as dewatering pipe. Then these are the filter media. Then this is the collecting point. This is the footwall with strainer and the submersible pump. Then at the from the ground surface, what we have to do? Seal with bentonite. So bentonite is the material by which we can seal or compact the nearby area of this, the you can say the suction pipe. And this is the another thing I would like to say in the next step. You can see here, I already explained earlier. This is useful for fine grain soil whose permeability is 10 raised to power minus 5 to 10 raised to power minus 7 meter per second. So it is necessary to apply a suction head in excess of capillary head to the dewatering systems. What we have to do generally in case of the vacuum method, a hole of 25 centimeter diameter is created around the well point and the rise pipe by jetting water under sufficient pressure. Then vacuum pump are used to create a vacuum in the sand filling. Okay. So with the help of vacuum pump we have to create a vacuum. Then when the vacuum is drawn on the well point, the ground surface is subjected to unbalanced atmospheric pressure. Then what is the purpose of this particular vacuum dewatering? Control seepage and lowering of water table to prevent piping and increase slope stability. So these are the purpose behind the vacuum dewatering. Now actually if you see in case of vacuum dewatering system or the working procedure, the borehole is taken up to a level up to which dewatering has to be done. Coarse grain material is filled so as to filter between the annular space up to 1 meter from ground level. Okay. So 1 meter space is filled by clay or bentonite. Then vacuum pressure is created which permit hydraulic gradient to water to flow. The water can then discharge. So this is the simple method by which we can dewater the area of for the excavation of the foundations. Then this is a simple working procedure. This is the vacuum we have created from the both sides, and this is the with the help of vacuum pump we have to create the vacuum. What is the purpose of creation of vacuum? See here you can see when the vacuum is drawn on the well point, the ground surface is subjected to unbalanced atmospheric pressure, and then the borehole is then taken up to a level which dewatering has to be done. Then coarse grain material is filled so as to filter between annular space up to 1 meter from the ground level. Then 1 meter space is filled by clay or bentonite. Vacuum pressure is created here. This is the seal of or the bentonite we have to use for creation of the you can say the vacuum. Then the vacuum pressure is created which permit hydraulic gradient to water to flow. The water can then discharge. So with the help of creations of the vacuum pressure is created with the help of vacuum pump, and ultimately what will be happening? The water will pump easily with the help of the submersible pump. Then water will come up to the ground level. So this is about the working of the vacuum methods. Okay. Then the here I would like to show you the how the dewatering process of the retaining structure will happen. So in case of dewatering the water from working area of the retaining structure, retaining wall, to retain the earth or the water from the foundations of retaining wall, to retain the water or earth. Okay. So in this diagram, if you see here, this is the water level. Okay. And what we have to do, if you want to excavate this area, now retaining structure is constructed on the bank of the river. Okay. If you want to construct the bank of the river, then what we have to do, put a certain kind of the sandbags, if possibly, if the possible, then we have to put certain kind of the sandbag to divert the water. And then from the excavation, we have to, you can say, require a pump setup. This is a suction pipe, and this is the area, actual area where we want to excavate the foundation for the retaining wall. And then this is a delivery pipe, delivery pipe. And then this is the, you can say, the retaining wall. Okay. Then retaining wall is having the hill and toe. So this is the toe slab of this particular retaining wall, and this is the hill. And then what we have to do, we have to strengthen the embankment. This is the filling with the help of murum, or you can say the soil, and we have to compact it. And this is the area where we want to actually construct the retaining wall. So this is the simple method by which we can dewatering the area. Okay. So now this is the simple method for the dewatering of the retaining structure across the river bank. So this process we can apply it for the dewatering of the for the constructions of retaining wall across the bank to protect the bank of river. Okay. So those who want to go in deep for the learning process, then there will be a, you can say, I have already uploaded the material for the study purpose. So go there and do the study how the retaining wall will constructed, and how the dewatering process will be done with the help of vacuum, you can say, the vacuum method of dewatering systems. So this is about the today's lecture. Then in the, in this particular session or lecture, I would like to take one or two questions. Then I request all the students, please please be a part of this particular, you can say, the activity of questions and answer. So in today's, the first question for the today's lecture, the first question is the see here, a deep well drainage system adopted when the depth of excavation is more than below the water table. So first option is 16 meter, then the second option 20 meter, then third option 25 meter, and the fourth one is 30 meter. So this is the question: deep well drainage system adopted when depth of excavation is more than below the water table. So this is the first questions. Then I request all of you be a part of this particular question. Then again, I would like to poll the another questions. The second most question is vacuum dewatering method is employed. Vacuum dewatering method is employed when the permeability of soil is range from meter per second. So first one is 10 raised to power minus 3 to 10 raised to power minus 5. The second option is 10 raised to power minus 5 to 10 raised to power minus 7. Then the third option 10 raised to power minus 7 to 10 raised to power minus 9. And the last option is 10 raised to power minus 8 to 10 raised to power minus 11. So vacuum dewatering method is employed when the permeability of soil range from meter per second. So these are the two questions. Simultaneously, I am going to download the attendance. So the okay. If anybody is having the questions, please ask. If anybody is having question, please ask your question.
Sir,
Yes.
there is a error occurring while polling the answer, sir. Giving the poll.
You can't submit the answer.
Yes, sir. There are many students are not able to answer the question.
Yes, I also seen the same problem here. Okay, I will discuss this problem with the Madik sir. Madik sir is the in charge. So while polling the answer, then such error will be there. So I will discuss this issue with the Madik sir, CSC department. So there will be issues. So what is the meaning of this? 83%, 57 student says 10 raised to power minus 5 to 10 raised to power minus 7. Okay, it is correct. 59
Yes, sir.
student, 59 student poll. Okay, so 5 and 5 students say that this is the answer. So exactly how many students are the part of this particular activity? 58. Then this is 59, and then this 5, then this 6. This is the count actually. Okay. So sum of the student. Who is this one? Okay, Prathamesh. Prathamesh,
Ji sir.
you are not able to submit the answer.
Sir, I don't know it is accepted or not.
But in front of you there will be a error. See here, Prathamesh, the ID, there will be an error has occurred. Okay. So I will discussing this issue with the other faculty. Okay. So today we will stop here. Thank you.